$1 million question: why we build bad software. Welcome to the part 3. So, really, this is a huge question. I asked myself why I'm building a lot of times bad software, because I did a lot of startups and I just realized none of those softwares, like business-wise, but none of those softwares exist anymore. And I kind of debugged myself and I tried to understand why this is happening. Excuse me. And there are common mistakes and like bad decisions that if we make, it's gonna be really, really tough for us a few months later on. And this is why we are gonna discuss this thing today. So what are those mistakes? There's no surprise that bad choice of database is one of the largest mistakes that you would make. Like, understand the one fact, that database is like the whole value, or if not whole value, but largest portion for most of the softwares and for most of the businesses. So what does that mean is, like, you might have a lot of softwares competitors and competing with each other, and just it's the matter of how much of a customer information one business has over the other makes sense and causes like one to succeed or one to fail. And one of the things I have seen ever is like bad choice of database, and this is why a software loses its value over time. And if you have this problem, it's going to be difficult to kind of query, kind of extend, and all of those bad things happen. And I believe the bad choice of database is the first thing to mitigate. So what are those things? In fact, what causes that problems? I think one of the most important, or let's say first item on the list, is choosing cloud-based database as primary resource. So as a small startup or even medium-sized company, you don't want to be attached to a cloud service, which gives you some kind of weird database system, regardless what kind of a database is. You want to be able to install the database on your local machine or even on-premise and store those information. You don't want to be adding the extra knowledge of and the maintenance of a cloud database as your primary choice. So if your software works locally, let's say with MySQL, and then you want to use AWS for that later on when you're deploying it, it's totally fine. But if you are depending on that kind of a database, which is like a real-time database or something in cloud, and your app has no way of working offline, this is very, very bad database choice. Second thing is not using relational database. So using kind of like JSON-based databases, nowadays there is like every week one of them, is very, very bad choice, and it causes so many problems. And I think most of them are from a decision point of view, because if you're using kind of a non-structured data, understand this, in this world we don't have unstructured or unorganized data. It just does not exist, and it's just gonna allow you to store them, things you don't want to query, things you can't really use later on. I understand there is way and there are solutions to that, but why you want to go from the beginning through that hassle? And in order to make a database very resilient and even install it on microcontrollers, the only real option is SQLite. And SQLite is an SQL database, relational, and if you're building your product on top of that, kind of it works in every environment. Like, could be a desktop app, mobile app, microcontroller, cloud, whatever you name it. And people I see build a software on top of that, and software over time has no value because it can't really generate good queries. it has like duplicate data. Yeah, in the beginning you say we will manage this, we will fix these things, we will take care of it, but if it's allowed by the database level, usually people over time don't care, and I have seen a couple of times people rewriting their entire application into a relational database. After a while they realize that. I don't remember who was it, but somebody was talking and mentioned that we store all the information that we don't need in MongoDB. So question is, why even store it in the first place? So just stick with the relational database if you want a reliable software which works in many places. I think the third option we kind of discussed here, and using Elasticsearch, for example, as primary database, or MongoDB as primary database, is just very bad business decision that you might do. And I believe there is no exception to this. I understand there are some cases that you can use them for like logging or for maybe other things, and but it's just not primary database. The fourth option is not normalizing tables. And not normalizing tables means this is kind of a relational database thing, but it's also a software thing. And for example, we could store the information of user email, password, first name, last name, phone number, country they live, the currency they accept in one table. It is totally possible, and it's totally fine from a coding perspective. But when you're thinking, okay, if you want to add like Google login, then what's going to happen? If the permission system changes, what's going to happen? So you need to have like this kind of a thinking in your software that you separate all of these parts and then connect them with the foreign keys, and to make it very, very editable later. And it is possible, but for example, for an authentication system, instead of 1 or 2 tables, you would have 13, 14 tables, like in Fireback, and something not so many people want to invest on. Therefore, I think the best choice here would be MySQL, and then after that SQLite. And if you really, really need a large amount of data that manage like entire continent or like every citizen of a country, then you might be thinking and discussing with the DBA and migrating to Oracle. In fact, I see a lot of softwares would work perfectly fine with MySQL or even SQLite. They don't need kind of this thing. And imagine when you're building your starter software, you think millions or billions of people are going to use it, but in practice, it's very, very hard to get even 10,000 users on it. And if you have 50,000 users paying for it, then you can optimize a lot of things, and you don't really have to be worrying about it in the beginning if you have good normalized database and great choice of database engine. So thank you for this section. I will see you in the next part, and we will discuss about the other kind of bad choices you might make.